actually for colleagues at work to begin with. It's changed a bit since then. I was working on a financial system, statistics about financials, and we had an ETL which, well, it went bad. So we tried to fix it and somewhat did fix it. So that's what this presentation is about. Some things about me. I'm old. I have 2 kids. I worked with SQL Server for roughly 20 years. The past maybe 10 years, that's the only thing I've done. So I used to be a half-bad .NET developer. Now I totally suck at that kind of things. I open solutions sometimes, but I don't even know where to look for the code. So I'm happy to work only with data platform. I am a database consultant, so it kind of works. I help you give me money, so please do. I work for food. Some abbreviations. I'm a certified trainer. That's the most important, I think. So I love teaching. I actually used to be an elementary school teacher for a couple of years, but we talked about money seconds ago. So this is more profitable and actually more fun to teach tech than try to get 15-year-olds to come to school. Well, football coach, scout leader. I run from time to time. I'm super slow and I'm kind of fat, but I like running. So I did a few marathons. My contact details, I'm on Twitter, on LinkedIn. That's the social platforms I use the most, I guess. I have an email. I'm a time zone traveler, which means parts of the year I live on well, mostly West Coast time. And it kind of sucks when you have office hours in Stockholm time, but it's worth it because if San Francisco 49ers beat Cleveland Browns 31-3, well, it's worth staying up for. Enough of that. So the ETL gone bad that I'm going to talk about. It's a monthly data load that someone, that would be me, implemented a few years ago. We got CSV files from the ECB, the European Central Bank, containing stuff about securities, financial securities like debts and shares and stuff like that. Lots of columns. I wouldn't say it was poorly data modeled. It wasn't data modeled at all. So it was just a flat file with tons of data. And we figured, okay, let's put it into a table, which is as badly modeled as the CSV file is, to begin with at least. And the things we were interested in were the securities which had a Swedish bank or institution that created it. So that's the only thing we were interested in. So we created one index on this table, which was a filtered index on country code equals SE. That was roughly 50,000 rows. But then I worked for the Swedish Census Bureau, and you have, I mean, statisticians or data scientists, they like data, so they started querying this table, and we ended up with something like 20 indexes on the table. So that's the background to it. In this presentation, it's going to be pretty boring if we sit there for 8 hours and wait for when it was bad. So I've created a smaller data set, but it's the same idea. We get 2 million rows of sales data per month in a text file, and we bulk it into a table. Table of 15 columns or so, and some indexes on classification columns. So this is the data model that we're going to work with, and the table in blue, the production sales table, that's the interesting thing. That's where we bulk the data into, and the rest is just to be able to query and make some classifications to it. So the ETL process version 1, I created an SSIS package to load the data. it was maybe a little bit more complex than this because it had some error handling and so on. But more or less, this is what it looked like. Flat file source and an only DB destination. And it just worked. For quite a while, it just worked actually. But then came the idea of actually querying the data. So these are some examples of the performance of the SSIS package that I just showed you. First execution took 28.972 seconds, so not that bad. Second execution, 55 seconds, and the third execution, 121 seconds. And why did it perform worse and worse? Well, after the first execution, someone created a unique constraint on the table, which is, it kind of happened to the data that we imported with the financial securities as well. So I tried that on my work data set, and well, it almost doubled the execution time, which makes sense. It's a unique constraint. The bulking into it is going to be quite different than not having it. And then after the second execution, someone created a couple of more indexes because we started to be interested in the data and started querying it. So yeah, that's the reason why the performance degraded. And if we would have just kept on loading without doing anything, of course, the execution time would be worse and worse because, well, more data already in the table, and then we put data into these indexes, and it's going to be page splits and sorts and what have you to put the data in. So we did a small change to the SSIS package. We disabled all the indexes, bulked the data in, and then rebuilt the indexes. Kind of a normal setup for an ETL. So not so much interesting to show. I'm going to move some windows around here so I see what I do. We added a couple of execute SQL tasks to the SSIS package. The first one contains this code. So some dynamic SQL, alter index, the name of the index, on the table, demo.production sales, and disable. And then we execute the data flow task, and then another execute SQL tasks, which does the same kind of dynamic SQLs, but instead of a disable, we do a rebuild of the index. So nothing strange. No matter where I move all these windows, they come in the way. But let's see. There we have the Visual Studio. So if this is version 1 of the ETL with the data flow task, it's just going to load. Flat file source, OLEDB destination, just as you saw on the PowerPoint slide. Version 2, execute SQL task to disable all the indexes, the same data flow task, and then rebuild the indexes. And this was kind of okay for a while. But it started degrading. So we had the data flow task taking roughly the same time every execution, but we have the rebuild index task, which took, well, first attempt 58 seconds, next time it took 69 seconds, and it's just going to take longer and longer unless I remove data from the table. And that's kind of sad. And maybe I should say about the real case that we had. We were loading data into this table, and then we moved it into a more normalized data model. And from when we got the data from the European Central Bank until we were to publish statistics about these numbers and numbers from other sources that we compared with, we had, I think, 4 days. And after a while, our execution of the ETL took up most part of one of those days. So it gave us only 3 days to actually work with the data, and that was too little. So we had to publish statistics that wasn't checked properly and so on. So we had to do revisions the month after when we found patterns that were odd and had to fix them. So yeah, it wasn't an acceptable solution. So when we had roughly 250 million rows, the performance had degraded so badly that it actually took 8 hours, a full day. We got the data in the morning, and then we had people sitting around waiting to start working, but they didn't get the data into the production system that they were using to actually check and change the data. So users were upset, and I was sad. That's the short story. So I was alone as a database developer in this project, and that's how it usually is, unless it's a very big project. So I was scratching my own head, looking around to see if any of the .NET developers had any good ideas. Well, they didn't. So I started Googling on partitioning, which I'd heard about. This was back in 2010. So partitioning wasn't something that everyone could use because it was an enterprise feature and not everyone had used it actually. It came in SQL Server 2005. And most people treat a feature that comes into SQL Server as something that is so new that you shouldn't touch it for a couple of versions. So it really not so many people used partitioning in their day-to-day system, in data warehouses, of course, but it wasn't widely spread. So I stumbled upon Kimberly Tripp's white paper about partitioning that was written when SQL Server 2005 was released. And I went back to it the other week, and it still holds. It's a good white paper. So if you just Google for Kimberly Tripp and partitioning, that would be probably the first hit. So it gives a really good explanation. It's maybe, sorry, Kimberly, it's a bit dry, but hey, it's documentation or a tutorial, but it works. You can still use it. So partitioning. Now we're coming to the subject of this session. When you partition a table, what you need to do is you need to find something that a key to partition the data on, something that can tell the difference between one month and the other, typically a date. Partitioning means that you physically store the different partitions that you create. We're going to talk more about what it actually means, but they're stored as separate tables. I put that in quotes because when you look at it, it has one object ID, but it's very similar to creating multiple tables and just do a union all between them. But they're logically kept together, so you have one object ID and you can query one object. You don't need to create a view or a complex query to do the union all. What you need to have is the partitioning key, the thing that you use to identify a partition. It must be in the clustered index. It doesn't have to be first, but it has to be in the clustered index of the table. And a very typical use case of partitioning is that you load data into a staging table and then you switch that data from the staging table into your main table or your partition table. And what you need is to have the same columns on the staging table and the target table. You need to have the same indexes on the staging table and the target table. Well, not the same name of them, but the same definition. The only thing that can be different is the compression, which comes in kind of handy because you can put in a data warehouse on a fact table where you have maybe one index only, you have a clustered column store, then you can do the archive compression on the old partitions and so on. So that's kind of handy. But apart from the compression, they have to be identical. And one more important thing on the staging table is that you need to have a check constraint in it, which ensures that all of the rows fit into one partition. Because if you don't, then SQL Server won't know that it can just take this staging table and move it to become a partition. We're going to look more into this, but this is the kind of helicopter view of it. Target table, which you switch the data into, it needs to have an empty partition. You can never switch data into a partition that already has data. Then SQL Server will complain. The target table has to reside on the same file group as the staging table. And the target table also must have all its indexes created on the partition scheme, which we're going to talk more about. But it means that not only the clustered index, but also the non-clustered indexes need to be partitioned. And partitioned the same way. And if you meet those requirements, then you can just bulk data into a stage table and then switch it into the target table in a couple of milliseconds is all it takes. So how is this magic working? First, you need to create a partition function. That's the first step of partitioning. And the partition function is not a function that we're used to, because we're used to a function that takes a specific value and outputs a specific value. That's a typical scalar function. A partitioning function, when you define it, you define what data type the partitioning key will have, and then you define boundaries for buckets. So for example, for dates, you define the date boundaries, could be the first date of the month, or the, first date would probably be a good thing. So first date of the month, or first time of the day if you partition by day. And then the partition function, if you call it, it will return a number, and that number will be the partition ID. Or the bucket ID, or whatever you want to call it. But the partition ID is what's used under the hood. When you've created the partition function, you need to create something called a partition scheme. And what a partition scheme does, it binds these buckets or partition IDs to file groups. So you create a partition scheme for a specific partition function. And in the example I'm going to show you, we're going to use only the primary file group, but you can use partitioning to move all data to slow storage, and then you would create file groups with files on the slower storage, and you would, with a partition scheme, define that the older buckets would be on the file groups with slow storage. But that's not in this use case or this case study. When we look at an ETL process, we're gonna have to have the staging table and the partition scheme, or at least the partitions that we're gonna bulk data into, have to be on the same file group. So we're gonna use primary. Plus I'm using my own laptop, so it wouldn't make any sense to create different file groups on the same set of disk drives. So, so the partition schemes are built on one or more file groups, in our case, on the primary file group. This picture is from the Brent Ozar starter pack. So if you register on brentozar.com for the starter kit, you'll get this little poster and some other useful things. At the first sight, it doesn't tell you much, but if you're new to partitioning, it's kind of good to have on next to your desk to take a look at to see the different objects. Oh, what does this mean? What's the key and what's the scheme and so on? How are these things connected? So you'll get that if you register for the starter kit on brentosar.com. I hope it's okay that I use this, otherwise you'll have to edit it out. But it comes with some, go to Brent Osar, there are tons of other good stuff. Plus Brent started GroupBy, so thank you, Brent. Partition function, let's look into that one in more detail. It has a name. The name could be anything, but as usual, use good naming conventions. Try to use the same naming convention every time you create an object in the same database, and use the same naming convention as your colleagues. That's super helpful.
I typically just name my partitioning functions PF. Let them figure it out.
PF only, okay. I give them a slightly more meaningful name, you will see. But no, my names don't add that much value to it. The partition function has an input parameter data type. So like I said, when you call a function, usually you give it a value or a variable name that has a data type. But in this case, you only tell which data type. And then you have a range direction. And what does that mean? Well, we're going to look into it a bit more in detail and see some examples. But what it means is that the partition function has a couple of boundary values. For example, the first of each month. And if you do a range left with your partition function, it means that any value that hits exactly the boundary is going to go to the left of that boundary, to the partition which is on the left side of it. And if you do a range right, it's going to go to the right hand side. So for example, if you partition a table on the with boundaries first day of each month, it would make sense to do a range right, because otherwise the first time, exactly midnight of that date, would fall into the previous partition, and then the rest would go into one partition. So it would make sense to use range right. Otherwise, you just have to tweak the boundary values. And when it comes to date time data type, well, we all know that it's not an exact data type. It's taking steps of 3 or 4 milliseconds between each distinct value. So it would be tricky to get it right. Using range right, we know that it's going to be right. And then you put in some range values. And the values are the boundaries. Let's say you have one boundary. That means you get 2 buckets, one to the left of the value, one to the right of the value. If you add more boundaries, you get more buckets. So if you have n boundaries, you get n plus 1 buckets or partitions. So we see here an example of a range right with an integer input parameter data type. So I have the green ones are my boundaries that I created the partition function with. So I have the boundaries 0, 10, and 100. The first partition, which is going to be to the left of the first boundary, is only going to contain negative values. Or if it would be a check constraint, it would be less than 0. Partition 2 is going to be the values which are between the first and the second boundary, including the boundary value for the first boundary, but not including the next boundary. So larger than or equal to 0 and less than 10, and so on. And then on the right hand side, you will have anything which is larger than or equal to the last boundary value. Once you get more data, you will typically add more boundaries to the partition function. So let's say you add 200. Well, that means you will have values larger than or equal than 100, and less than 200, and then the rest on the right-hand side. And you kind of need open ends, because otherwise you create a check constraint for yourself, which you probably didn't want to. That's why the partition functions, they will be everything to the left of the first boundary will be the rest, which is lower than the first boundary, and on the right-hand side, the rest, which is larger than or equal to it. So let's create some partition functions. I'm going to create two. These are not named PF something, but other ones might be. Create partition function. That's the command you're doing. You give it a name, 4 integers right in this case. The parameter to this function is the data type int. And then you say that you want it to be a range right. So I'm doing it with something hitting the boundary value is going to go to the right of the boundary value, to the partition to the right of it. And then the 4 values clause followed by a tuple of values will define my boundaries. So typically this one, it creates 3 boundaries, which means 4 buckets. And this is the exact same thing I had on the slide, actually. I'm going to create another partition function with a range left for the same values. And remember, this is just a function. I haven't partitioned any objects at all, but I can still check what the function would return for different test values. By using the function $partition. So if I say select $partition dot and then the name of my partition function and a value as a parameter, the $partition function is going to apply the partition function with this value and return which partition ID would a value would this value come into. So let's try with -1. They all come into partition 1, which is the first partition. It's a 1-based array, if you like. If we test something more interesting, we put in the boundary values, 0. 1 is actually not a boundary value, but 10 is, and 100 is. And we run this select, and we see that the 0 for the range right function comes into partition 2, but the 0 for the range left function comes into partition 1, so it stays on the left-hand side of the boundary value. Same thing with the 10, and same thing with the 100. And then we become above the rightmost boundary value, then of course they fall into the same partition. My advice when it comes to choosing range left or range right, be consistent, because it's going to be confusing otherwise. If you have more partition functions in your solution, then use range left or range right. Don't mix them too much, because it's going to cause confusion and complexity to your ETL, because you need to fiddle with these partition values when you get new data in, and it's always nice to have a consistency. So let's take this table demo.production sales and partition it, because that's a thing that you probably will fall into. You have tables which are not partitioned, and then one day there is too much data and your ETLs are running too long, or some other reason. You want to do housekeeping, so you want to clean out old data, and that's another good thing about partitioning. It's very handy. So let's see how we take an existing table with data and partition it. My table right now has roughly 10 million rows. So it's not super big, but not tiny either. First, we need to choose a partitioning key. And since I have a date in my table, and I know that the data I get in from my text files, they will always have a new reference date. And it's always going to be larger than the previous load's reference date. This is just my use case. It could be that you will get revisions of old data, and that's going to complicate things. But in my case, everything is newer than the newest data I had in my table before. I could have used the production sales ID, which is an identity column, but it's a bit trickier because then I would have to find out what's the highest key right now and so on. It would make a smaller clustered index, which would be nice, but I stick to my reference date. So the reference date needs to be a part of my clustered index. It doesn't have to be first, it doesn't have to be last, it just has to be in there. But since I keep my production sales ID as well because I use my clustered index as the primary key. So it's a good thing. The production sales ID is ever increasing. So within each partition, I won't get any page splits because I try to put data in between or anything. And if I wouldn't have a unique clustered key, SQL Server would add a uniqueifier, which is, I don't know what, 12 bytes or something, which would make it even bigger. So I put the production sales ID there as well. I put reference date as my first column because my queries usually have the reference date in the where clause. So it makes sense. I wouldn't do any kind of range scans based on the production sales ID because the date is the logical key in a way. And then I need to create a partition function, and I use the date data type. Typically, if this would have been, I don't know what, a fact table for orders or anything, I would have a date key of some type or a date time or whatever, but I have date, so no time information in it. I do a range right. It says on the slide no obvious reason, but actually it has an obvious reason because if I use the first of every month, then I know that every month has a date which is the first. Every month doesn't have the 30th or 31st or anything. So if I use the first day of month, then I use a range right because then I would include the first and the rest of the month in my partition. And then the range values I create, I put in all the already existing reference dates from my table as boundary values. And then I put the range value of the next month's last day. And that's kind of to create an empty partition in the end. So that's the range values I'm going to create in my function. Partition scheme, a lot simpler. I put all my partitions to the primary file group. It allows for fast partition switching, and well, I only have the primary file group as well, so it's hard to do anything else. But it's something you need to specify when you create the partition scheme. Which file group or file groups will I use? And you can either do it by saying all to primary or all to a specific file group. But if you want to mix, you need to define which file group every partition goes into. So either all to a file group or a list of file group, which is the same number of file groups as you would have partitions in your partition function. So that's the kind of metadata objects that I've created, the partition function and the partition scheme. And then I need to go ahead and actually partition the table. Here comes the offline part of it. I need to drop the clustered index to partition a table. There are actually other ways to do it. What I could do is to create a new table where all the existing data would fit into one partition of that new partition table. Then I could take my old table and kind of switch it. But no, I couldn't. I still have to have the clustered in the partitioning key in the clustered index. So forget that I said that. So I need to drop the clustered index. That's going to take some time. And then I need to recreate the clustered index on a partition scheme instead of a file group. You know, if you create a clustered index, it's going to be created on the primary file group if you don't specify anything else. In this case, we need to specify that it's going to be created on the partition scheme instead of a file group. And then you need to recreate all the non-clustered indexes on the partition scheme. And since you're going to have downtime anyway, you should do this actually in another order. Drop the non-clustered indexes first. Then you can drop the clustered index. Because what's going to happen if you drop the clustered index first, on the leaf level of all the non-clustered indexes, you're going to have the clustered key value. But if you drop the clustered index, there's not going to be a clustered key value. There's going to be a RID pointer instead, because now effectively our table is a heap. That means you're going to have to update the leaf level of all your non-clustered indexes, and not just an update. You're going to get page splits, tons of them, because the RID pointer is bigger than my clustered index. So drop the non-clustered indexes first if you're able to do this in such a long downtime window. If you want to do it as online as possible, then, well, dropping the clustered index and recreating the clustered index, it could be online. And then you could do a rebuild of the non-clustered indexes as an online operation as well. But since I work with cheap, I do standard edition, so online index rebuilds is not an option anyway. Yeah, so that's the existing table. Then to allow for partition switching of new data, we need to create a staging table. It's kind of easy. We create a table which is identical to our main demo.production sales table. And when I say identical, well, it can't have the same name, but it has to have the same columns and data types. It has to have the same indexes, the same index definitions. So let's see at how we can do this. And I don't know if you ever watched any like cooking programs. I did some of this in advance because it's kind of boring to look at dropping the index and recreating and so on. But we're going to go through the whole script and some of the things I already run. First thing I need to do is to find out which dates do I have in my table, because these are my boundary values. So I do a select distinct reference date from demo.production sales. I see that I have 5 distinct dates. The 1st of January, February, March, April, and May. Good. So then I can go ahead and create my partition function. So I create my partition function. I call it, wait for it, pf_demo. It takes a data type as the parameter. And I do a range right for the values 1st of January, 1st of February, 1st of March, 1st of April, 1st of May, and then I add 1st of June to create an empty partition in the end of the table. You don't have to do this. You can split the partition afterwards to create a new empty partition. It's up to you how you want to do your ETL. I like to have an empty partition in the end so I can switch data into it, and then I create a new empty partition after that, or as part of my ETL, but it's up to you when you do create that last boundary value. Then I created partition scheme, and mine is really simple. Create partition scheme. It has a name, ps_demo. As partition, the name of the partition function, and then I state that I want all the partitions to go to the primary file group. So all to primary. I don't know how many times I've missed the parentheses. It's more than once. They don't make sense to me when you do all to one. It's not a tuple, but it has to be with parentheses. So I already did this. And then I can check. Instead of just doing a distinct reference date, I instead do distinct $partition.pfdemo of the reference date. And then I query the reference date as well. And we will see that 1st of January falls into partition number 2. 1st of February falls into partition number 3, and so on. So we have partitions 2, 3, 4, 5, and 6 that has data in them. The reason I don't see the other boundary values is because I query the table, and the table doesn't have any other reference dates than these. Then we go ahead and drop the primary key constraint, which is my clustered index. I do an alter table and add the primary key. This time with the reference date and the production sales ID. Previously, it only had the production sales ID in it. I put some data compression, page compression, because my disk drive is not that big. Generally, page compression is not something you would do on data that you query a lot or write to a lot, but it's okay for this demo. Row compression is a free lunch in most cases though. And instead of creating it on a file group, I create it on my partition scheme, and I state that the reference date is going to be my partitioning key for this. When that's done, we can check the partitions that we have for our table using the view sys.partitions. And I check specifically for index ID equals 1, which is always the ID of my clustered index, if I have one. And we can see here that we have in partition number 1, we have 0 rows. In partitions 2, 3, 4, 5, and 6, we have roughly 2 million rows. And then in the 7th partition, we don't have any rows. This is super handy if you want to have, if you want to do a count of your table. Just count everything or count whatever is in between different values. Well, use the sys.partitions instead of doing a count, because doing a count star is going to be a scan operation. This is just going to check. You can sum up these the rows column, and you will get the count from the table. That's kind of handy. I use it all the time if I want to have a quick number. We have other indexes. If I didn't do things in advance, this would have shown that we had partition ID equals 1 for all of the non-clustered indexes. But since I already recreated them, we will see that also the non-clustered indexes are created on the 7 partitions with, of course, the same row count as the clustered index. I would be really scared if I had a different row count for the non-clustered ones. So the rest of the script is create index with drop existing, data compression equals page, and instead of on primary, I do it on PS demo with the reference date as the cluster, the partitioning key. Same thing as the clustered index. And then I had a unique constraint, which I had missed initially. So I do the same thing. With a unique constraint, you can't do create with drop existing. So you need to drop it and then add the constraint again afterwards. Now the table is partitioned. So let's create a staging table. Create table, same column, same data types. The only difference is that it's called demo.production_sales_staging. It could be on another schema if you like that, but I didn't. I have the same primary key constraint, and I have the same unique constraint as I have on my production sales table. The difference is that I create this on the primary file group, because the staging table isn't partitioned, it's just a table. What next? I need to create the same indexes. So let's do that. Also on primary. And when that's done, since this table had no rows, it takes 0 time. I'm done. I've partitioned my table and I've created a staging table. And we can go back to here. So the execution time. Yeah. Execution time is now constant. It's around 45 seconds for my ETL for my data set. In my production scenario, the real case, we were down to 20 minutes. And we had a consistent time. It took 20 minutes every month, regardless if the table had 2 billion rows or 3 billion rows, because the staging table, it had the same number of rows every month, or more or less at least, and switching it into an empty partition is always going to take the same time. So 20 minutes and consistent. So suddenly users were happy again. And deleting old amounts of data which are no longer used is just a metadata operation. It means you switch out the data. And then you can just truncate the staging table where you switched it to. So it's super handy instead of having like batches of... Sorry?
I was going to say, if you're on SQL Server 2016, I think you can now truncate table on a partition, which is super, super helpful. It eliminates the switching thing.
That is so true. Yeah, it's another operation that you don't need to do. And then you can truncate the partition, and then you can merge partition to remove all boundary values. It's a super quick thing. Let's look at switching out some data.
For a question. Yeah. So there's actually a question from JD. Would you recommend using this when records are input one at a time through a front end or by a lot of different users? He emphasized a lot.
Oh, I love the answer that I'm going to give you. It depends. It depends on how you're going to query your data more than anything else. Because if you do inserts row by row, then it's super handy to have a partition table if you clean out old data, because then you can do the switch out or truncate partition. So then you really have a use for partitioning. It's also super handy if you always query for specific dates or specific something that is defined by the partitioning key, because then SQL Server will know automatically from the metadata that the value you're searching for can only exist in partition number X, and it will just skip the rest of the partitions. It's called partition elimination. And but there are some other use cases which they are in my demo scripts. I probably won't have time to run through them. But there are some cases where your query performance will be horrible by just having partitioned the table. It's specifically max and mean queries. where you don't have the partitioning key in your predicates. That's going to mean scan operations, where min and max usually would just mean go to the rightmost or leftmost leaf level. So.
And we got a clarification from JD. He says, actually, for the specific example I'm thinking about, unfortunately, no data can be deleted ever, and searches can span almost anything. So,
okay.
So that's pretty much what you mentioned, right?
Yeah, there could be a benefit still, because what you can do is you can do your index maintenance partition by partition. So if you are on standard edition, that would mean you don't block the whole table while you rebuild indexes. And it could very well be that you don't update old data. Well, then you never need to do index maintenance on the old data. You just need to do it on the newer partitions. So it could take your maintenance window down a bit. Yeah, merge range if you want to. Let's look at this. But before we do, actually, we should look at how we do the actual load with partitions, because that's more interesting than switching data out. That's a very simple thing. This is a bit more complex. So our ETL that we built, we're going to mimic it by inserting one row to begin with. So I insert one row into my staging table. Oh, thank you. Well, didn't I create user objects in master? That's why not? So I have one row, and now this row is for the 1st of June. As you remember, we only had data for May before, so now we have one row in the staging table for June, and we want to somehow get it into our table demo.production sales. It's just one row, so we could have done an insert, but imagine it's 2 million rows. It's going to take a bit longer. And with this technique, we just lock a staging table that no one is querying while we insert, and then we could do the switching. So to do that, we need some variables to hold some values. We need a variable for the partition number, because we're going to find out which partition number will we switch the data into. I need the reference date from the staging table. I need, we'll talk about this soon. I need the next boundary value, because I need to create a new boundary value in my partition function as part of my ETL now. And then I need a placeholder for some dynamic SQL. So the reference date, I just do a select max reference date from my staging table. I can do this because I know that it has consistent data when I load it. You might want to have to check that you have just unique values, or which range of values do you have. But in my case, I know it's just one date, and I can trust the ECB to not mix dates in the data that they send to me. This variable, I use it to get the sum of rows from syspartitions for the partitions where this new reference date would go into. So the reference date from a staging table, what I use it for is to just make sure that I don't already have that date in an existing partition with data in it, because then I can't do the switching. So then this horrible spaghetti code with if and else down below, but if I didn't have any such rows, then I can go ahead and do the partition switching. So I figure out the next bound, which would be the end of month for the reference date plus 1 day. Then I have to use some dynamic SQL to alter table on the production sales staging table. I need to add a check constraint to it, because I need to tell SQL Server that this table only contains data within a date range that fits into one partition. So with check add constraint production sales bounds, and what I'm checking is that the reference date is larger than or equal to the reference date that I have in the staging table, and it's smaller than the next bound that I just figure out by this EO month function. And then I execute that dynamic SQL. I have to tell that the next used file group for my partition scheme should be the primary. And then I can do alter partition function, the name of my partition function. Don't forget the parenthesis because it will fail otherwise. And then you split range. And split range means introducing a new boundary value. And the new boundary value I introduce is the next bound, which will be the first day of the next month. I execute that, and then I find out which partition number do I have for my reference date that I have in the staging table. And then comes the magic. I alter my staging table, alter table, demo.production sales staging, switch to my main table, demo.production sales, and I tell that I want to switch to partition number and then the number that I just found out by using the $partition function. And then I execute that. And the last step is to drop the check constraint on the staging table, so I make it ready for a new set of data to come in the next month. And then otherwise, if I did have data already in the partition that I want to switch to, then I throw an error. Let's run this in one sequence. And it's done. And of course, it's one row that I moved, so it should be quick. But if it would have been 2 million rows, it would have been quick too. So I check the staging table, which is now empty. And if I do a count star on each reference date from the table, I will see that I now have data in partition number 7. One row of data.
This is pretty amazing stuff. Just to amplify what you're saying, it could have been 1 trillion rows in that staging table. The metadata operation would still have been the same, and it would still have been instantaneous.
Yeah,
I think this is magic, and I think there are going to be a number of users who take this YouTube video when it's going up on YouTube and just stepping through it and trying it in their own environment. So it's pretty cool.
Yeah, it is actually. So when I look at my ETL, the thing I've introduced is this execute SQL tasks, and the code it contains is this code here that we just went through to do the switching. And we could actually try to run that package because it's pretty quick. If I do execute SSIS package, this is something cool with SQL Server 2012 and onwards, where you do the project deploy and you can execute your packages from T-SQL without having to start up the DTExec and so on. So I execute the package. I get an execution ID for the package, which is number 36. And then we can look at the report, all executions. Hopefully it should be running without errors. And if we hit refresh a couple of times, this should be done in, I don't know, roughly 30 seconds. It's fun.
An SSIS package without errors, you're really setting the bar high. In a demo and everything.
That's why I keep it so simple, because every time you introduce any complexity whatsoever, it's bound to fail, especially when you do like me. I copy paste objects between control flows, and well, that just doesn't work. It's a really fast product that is absolutely super hard to use, unfortunately. I like Bimmel, so I need to learn it someday to generate packages with code instead of just drag and drop. And yeah.
Biml is also super cool and really, really hard to learn. I think it's really simple when you see it, right? But I think it's hard to.
This actually took 70 seconds, which is always when you do a demo, it takes twice as long as when you rehearse it. We can go in and see which step took the most time, and it was the rebuild indexes took 29 seconds, but the data flow tasks took 36, and usually it runs a bit faster. But hey, it's a consistent. Probably it's because I do video and it uses up 1 or 2 of my cores in my computer. Normally I don't do videos on my database servers. I don't know about you, Daniel. Do we have time to look at one complexity about the partition table?
Do it. It's just a lunch break.
Good. So the switch out, I'm going to skip it, and you can just, I'm going to upload my demo code to probably some GitHub repository.
Maybe you can put a link in the original post on groupby.org so people can find it.
Yeah, I'll do that.
Cool.
So we're going to start with something which is, I found out when I did the rehearsal for this demo. Originally, I started off with 2008 R2 as the version for SQL Server when I started doing this demo. And now I'm on a CTP 3.1, I think it is, for SQL Server 2019. So I just do a count star from demo.production sales, where reference date equals 2019-0301. And I'm going to include the execution plan. And I'm going to be in the right database when I do it. Here is the execution plan, and I mean it doesn't look very strange. It's an index scan. It's a hash match aggregate. It's a compute scalar, which I don't really know why I have, but let's forget it. The big thing is I scan data, I aggregate it, and then I gather streams because it's a parallel plan. But if we look deeper into the index scan, the first thing that I stumbled upon when I rehearsed is that it's running in batch mode. Batch mode is something we only had for column store indexes. Now it's a row store thing, which makes this a whole lot faster than if I would have run it in row mode. But that's not the thing I wanted to look at. If we do properties for this operator, we're going to find some. First of all, the properties are a bit different because it's running in batch mode. But we will see that the table is partitioned true. And we'll see some funky seek predicates. Let's open it up. We'll see partition ID 1000 equals scalar operator 4. Huh? What does that mean? It has, I mean, I don't define any such values, but what SQL Server does is it creates a list of the partitions it has. I mean, that's 8 right now. And then matches this value to the partitions. So the partition ID should be 4 because it knows that this data can only be in partition number 4. And
so this is the partition elimination part.
Yeah.
Yeah.
And in batch mode, it's going to look like that when you look at the properties for the operator, that you will have some seek predicates which look a bit funky, but this is what you will look for. PTN ID something something equals scalar operator and then a number. If I just, for the sake of it, take my database and change it to run in a previous compatibility mode, we will get this query to run in row mode instead. Let's put it to 2016. We run the same query. We get an execution plan where instead of having that magic down here, we have actual partitions accessed. Yeah, number 4, that's the partition we accessed. Actual partition count, 1. So SQL Server only accesses the partition where this data can be. It wouldn't make sense to scan all the other partitions because this date can only be in one partition. So that's kind of an optimization that we get from the partitioning. Let's look at something a bit more evil. We do max on a column called production company identifier. It's indexed. It's in an index that is partitioned because all my indexes are. And I run it. There was a reason for the max.1 as a hint here. I'm not sure why right now. But if we look at the number of logical reads, it's almost 20,000 pages accessed by this to get the max of a column that is indexed. Normally on a table, when you do max on an indexed column, you would get 4 or 5 depending on the depth of your index. But no, this is no good. And the reason is because the table is partitioned. The max value could be in either of the partitions. And then I would hope that SQL Server was smart enough to do this simple loop of finding the rightmost value on the leaf level in each partition and then figure out what's the biggest one of these. But it's not smart enough. The optimizer is, the people behind the optimizers, they are geniuses, but this they haven't fixed. It's because there is a workaround which they think is simple, but it looks a bit complex to most. So let's look at how we would make this run fast. What we would do is I use a common table expression, which I call CT partitions. I select the partition number from syspartitions for my object for the clustered index, because I only need to find the partition numbers. So one of the indexes is what I use. Then I take out the production company identifier, which is the column I wanted to do a max on. I do that from my partitions that I have in my CT above. I cross-apply it to max production company identifier and call it production company identifier from my table where the partition number equals the partition number of the reference date. So for each partition, I get the max value. So if we would look at select star from CT production sales, which would be the first step, we would get for each partition what's the max value. So Shimano JP and 1, 2, 3 and null is what I have. But instead of returning that list, I do a select max production company identifier from that result set that I got, which is, what did I have, 8 or 9 rows. So if we run this whole query with statistics.io on, we get the same result. We get 20 logical reads instead of 20,000, plus some logical reads in some metadata tables, sys row sets, and then a work table because we have a common table expression that we're querying, but it's not actually read. The execution plan, it becomes a bit more complex because it will contain some system tables. But yeah, this is what the route you would have to go if you have max and mean queries on indexed columns, but you don't have the partitioning key in your predicate. So some rewrite. Most developers don't like to rewrite a whole lot. Probably you don't have to rewrite a whole lot, but this is kind of the warning. If that's your use case, that you do min and max queries on other things than the partitioning key, and the partitioning key is not part of the predicate, well, then you will end up having to do this. I think that's all.